Morning, good afternoon, good evening, depending on where you are. Welcome to this webinar on foundation decarbonization and reuse. In previous webinars that we have prepared, we talked about the potential for foundation reuse. And one of those webinars with Natalia Rosinska from Manar, we talked about the perspectives that the different stakeholders have when it comes to foundation reuse. So we know that different stakeholders have different views on this issue. And what we're trying to do today is give you a complete overview of one particular project where we let the owner, as well as the engineering firm and the various parts of that engineering firm, explain what happened on a specific project to see how you can work together to make this thing happen. On top of that, for this project, a very extensive test study was done that really covered all the aspects of the investigation, whether foundation reuse makes sense or not. That gives you a good overview, all of you that are either viewing this webinar live or will see the recording later on, a good overview of what steps you need to do beforehand to analyze the option for foundation reuse. With that, before we go to the next slide, just a quick reminder for the attendees, your microphone has been turned off, you are muted, but please participate in this webinar through the Q&A box that you see at the top of your screen. Put in there your questions, and after the presentation, I will moderate those questions. And with that, Lisa, if you could go to the next slide, please. For this presentation today, we have three individuals that will do the presentation. One should be familiar for you that have already been involved with previous webinars. Tony Sangiuliano, the Ministry of Transportation in Ontario. He is back with us today to talk about this project in Toronto. And we also have Lisa Coyne and Riley Shuster from WSP, who will explain what is going to happen and what kind of work they have done for this specific project. With that, Tony, the floor is all yours. Let's kick it off.
Thanks, Gerald, and good morning, good afternoon, good evening to everybody. We've got something prepared here for you today, and you could see that the slide identifies the outline of what we've got planned and organized, and we'll deliver this to you. So when you look at the outline, we're going to get things started by just talking about the Ministry of Transportation of Ontario's position on foundation reuse, and I will be delivering that part of the presentation. Then we'll get into the specifics about the particular project, which I think you're going to find quite fascinating, if I could be very impartial and unbiased about this. And there's various aspects about the project specifics that we're going to be talking to you about, as indicated on the outline. So we'll be talking to you about the project and site overview, some of the design considerations, summary of the desktop assessment elements, taking a very deep dive into integrity and durability, and sharing with you the risk assessment mitigation on this particular project and what we're going to be doing on this particular project moving forward. I do believe that what you're going to hear this today is what I call a win-win situation. And I always maintain that to be a winner, you got to think like a winner. And I would be remiss if I didn't, at this point in time, being from Toronto, and with the Toronto Blue Jays playing the New York Yankees tonight, still maintaining my professionalism. I'm going to put my Toronto Blue Jays hat on in advance of the game tonight. So with that being said, Lisa, can we go to the next slide, please? Ministry of Transportation of Ontario. This is a slide that identifies our assets, of which we've got approximately 17,000 kilometers of highways, over 3,000 bridges, 5,000 structural culverts, not to mention over 50,000 non-structural culverts, Our total asset value is about 100 billion. And, each and every day we move about $3 billion of goods and services. Now, when you look at the right-hand side, the bottom right, there is a bar graph. And that bar graph is a graph that illustrates our bridges, the number of bridges, and when they were built. And you could see a lot of our bridges are aging, they're getting older. And with this, we need to make some fundamental decisions in terms of what we're going to do moving forward with this bridge asset. Next slide. So, first bullet, how do we manage the aging infrastructure? This is a challenge that we have. Do we replace the bridge? And if we replace the bridge, do we replace everything? Superstructure, substructure, foundations. Do we just invest in new bridges? These are the types of decisions that we need to make. But keeping within the framework of the foundation reuse, of course, we're looking at trying to reuse existing foundations, which I think we all know has significant value in many ways. So with this understood and recognizing that we could save cost, time, and have also some environmental advantages and sustainability advantages, we at the Ministry of Transportation of Ontario have put a lot of thought into the foundation reuse. So with this being one of our strategic priorities, we're looking at the reuse of existing foundations to be considered on every project. So, we're undertaking on every job, and we've got it in our scope of work. By the way, we do outsource most of our projects to engineering service providers. So we, in our terms of reference and in our policy, identified that we want reuse of existing foundations considered. Not suggesting that it's going to be the preferred option, but we want it considered and assessed on each and every job. So a comprehensive process and procedure for assessing the risks and feasibility of reuse of foundations on each and every project is what we're looking for as a service and a deliverable as per the requirements of our terms of reference. Next slide, Lisa. So we do have a guideline that helps us navigate us through so that we could make informed decisions as to whether or not we could reuse existing foundations. So included in this guideline, as indicated on this particular slide, we look at a preliminary assessment of capacity, integrity, and durability. We undertake a risk analysis. We do a life cycle cost assessment. We do an estimation of remaining service life of existing foundations. And of course, we consider the environmental and social advantages. Next slide. In parallel, demonstrative of our commitment to the reuse of existing foundations, we take a lot of pride at the MTO to making smart investment decisions. And as you could see by this particular slide, we are investing in further research above and beyond our commitment to program delivery. So as indicated on this particular slide, we are engaged with local academia to come up with province-specific tables to assess corrosion as a function of the aggressivity of the soil and groundwater. We're aware that other jurisdictions like Caltrans have a similar, guideline, the Eurocode, but we're trying to produce something specific for Ontario. And we're hopeful that this can be used to help our designers to determine any mitigative measures for new piles, such as sacrificial thickness or coatings, but also, of course, to assist in the prediction of extended service life for existing piles. So with that being said, really pleased and proud to pass it over to Lisa and her team, who we've engaged, WSP being the service provider, to help us out with this particular project that she's going to share with us. Lisa?
Thanks very much, Tony and Gerald, and good morning, afternoon, or evening to everyone attending. I'm going to bring you into Toronto. I live near Toronto, and this particular project is in mid-Toronto. It's on Highway 401. Any of you who are in this area have probably cursed your commute at various times, in that this is often ranked as the busiest highway, certainly in North America, if not the world. 500,000 cars per day. And right now at mid-Toronto, and zeroing in on this site, we've got a core and collector system, or 13 or 14 lanes plus speed change lanes. So an extremely busy stretch of highway, as Tony noted in his bar histograph earlier. Lots of infrastructure that was built in the 1960s and that is approaching a time when we need, at the very least, superstructure replacement. So here's our site. This is Highway 401. And in very short succession, we have a very busy rail line, a local road that is also extremely busy and has a hospital just up to the north end of the screen here. And then we've got a river valley in this area, and one of the sort of 20-ish meter deep incised valleys typical in the Toronto area, right in this stretch. And all of these features are within a few hundred meters of each other. Right now, you can see on the screen that there is some construction underway. This ramp bridge has already been reconstructed a few years ago. It was realigned in order to be able to remove the existing ramp to make room for what is currently under construction, which will be new eastbound collector lanes. And you can see the bridge over Leslie Street and the Don River here. And you can't quite see in this Google Earth imagery, the foundation substructure was in place in what used to be a ramp bridge footprint, but is now the footprint for the new eastbound collector lanes. Traffic from existing eastbound collectors is going to be shifted downward, and these eastbound collector existing lanes are intended to be reconstructed as the new eastbound core lanes. So given the complexity of this area, very busy traffic, proximity to rail line, busy road, river valley, reuse, replacement of these bridges, and potential for reuse of existing foundations per MTO's policy and guideline was of particular interest, some real advantages here. So we're going to walk through a little bit of the background, and really, I'm not going to go into details. I can see I've got a bunch of geotechnical folks that are on this call. We're not getting deep into the details of how did we do our calculations of capacity, but really to try to paint an overview picture of how we ran through the desktop study and came to our conclusions. So this is a bit of an oblique view of the area. We have existing 16 span structures. They go from west of the rail line over to east of Leslie Street. And there is actually below the Highway 401 deck, there has been a parking area and a rail passenger transit terminal right underneath this area. As we go forward to replace these superstructures, this area is going to be infilled so that we have a multi-span or 3-span bridge at the rail line and a 4-span bridge over Leslie Street. Don River, I am not going to speak to in this presentation because there's a complete change in the span layout at that location. So unfortunately, we don't have an opportunity for reuse at the River Valley. But we've got these existing 16-span structures that were constructed in the 1960s. They've been rehabilitated. Superstructures are really approaching the time where they require replacement. And this is a multi-year process. We're moving the new eastbound collector now, but we've got to sequentially then work through eastbound core, westbound collector. We have an opportunity to reuse 2 piers at the rail west side and east side, and then 3 piers, west side, center, and east side at Leslie Street. We have not considered the abutments at either of these structure sites because we do have new span configurations in some respects, and also an intent to likely replace those with integral abutments. So we need a different deep foundation layout for those. These are a copy of the 1960 era design drawings, just showing the series of structures, but the bents in question. And certainly an interesting project, and one that is demonstrative of MTO's commitment to sustainability. So moving from Tony's summary of the guideline that MTO uses, I would say there was a very comprehensive set of terms of reference set out in the request for proposal. It did require a desktop foundation assessment be completed, looking at the subsurface conditions, looking at the design that had been made in the 1960s, the past performance of the foundations for these structures, looking at how those are geometrically compatible with, can we reconstruct? We're setting the stage for reconstruction or replacement reconstruction of all of the, sort of cascading onto the remaining structures north of these ones. And so really giving some good thought to that geometric compatibility, looking at the capacity, but also integrity and durability of those foundations, looking at constructability, and moving on from that into a look at a risk register. All of this has been sort of a predecessor to and in conjunction with the investigation work that we're doing and the design that is progressing. We're in between 30 and 60% design at this point. During the RFP, and this goes back a couple of years now, an addendum did come out, and I was especially excited about the addendum, which I think really looked at Ministry's commitment to foundation reuse. It had included, there's a ramp bridge I mentioned that was demolished in this area, reconstructed along this alignment, but the existing foundations were left in place. Superstructure taken down, but everything from pile caps down was left in place. And to get access for the contractor to come into this area to reconstruct, they were either going to have to do some tricky burying or some removal of the pile cap. And an addendum had come out to look at exposing selected piles, completing some pile integrity testing, static load testing, dynamic, sort of high strain dynamic testing to look at capacity, look at depth, and extracting some piles to look at their condition. Unfortunately, that addendum work did not ultimately go ahead, but during the work on this contract here that is currently under construction for the eastbound collector lanes, the ministry had an opportunity to have that contractor demolish the pile cap and expose the upper portion of piles, extract some pieces, send them off for testing. So while we're largely a desktop study, we've had this wonderful opportunity to take a look at the condition of piles that were constructed in the same era in the 1960s that have been not quite at the bridge location in question, but very near, within less than 100 meters from the site, and take a look at that condition and allow that to feed into the work that we're doing. Just a quick overview of the subsurface conditions. This is an image of the area showing boreholes that have been done over phases since the 1960s. We have more than 30 boreholes in the area solely of the new collector, existing core. We have not even shown boreholes further north for the remaining structures, which certainly reinforce the subsurface model and give us quite a bit of confidence in those subsurface conditions. We took a look at all of that, as well as some pile load testing that was completed in the 1960s, feeding into the original structure construction. And out of all of these phases of investigation, certainly the more recent work did include soil and groundwater chemical analysis for a suite of corrosivity parameters. Just a very quick snapshot. This is taken at the rail bridge. We have existing embankment fill. That's largely to the west. I mentioned there's a 16-span structure to the east. There is a near surface deposit of sand to silt type materials, generally loose to compact, sandy silt, silty sand. There's a shallow aquifer associated with that, a groundwater level that is generally within a couple of meters below either the rail grade or the Leslie Street grade. That is underlain by 10 to 12 sometimes even 15-meter thick layer of a more compressible, firm portions, but up to very stiff portions of clay, silt to silty clay. And then down in the range of 15, 20 meters, a little over 20 meters, depending on where we are for these bridge sites, there's what we call in the vernacular here 100 blow till. So high standard penetration test end values of this glacial till deposit in this range, a lower sand and bedrock that sits in the range of 30 to 35 meters below either the rail grade or the Leslie Street grade. When we looked at that information, I've boiled everything down into a single slide here in terms of looking at what are the foundations. And this belies the complexity of combing through all of the contract documents from the 1960s, the design drawings. Unfortunately, we don't have a lot of there are no as-built drawings or actual pile driving records, for example, not in any complete sense, but we did find lots of construction notes. Some of these bents for the 16-span structures are supported on caissons. There were some challenges with those, and reflected in those notes are some discussion around pile installation. And long and short, and boiled down into a single slide, we were able to work out with a degree of confidence that the particular foundation elements we're looking at are supported on steel H piles. They're 310 by 79, so a lighter section. The numbers of piles, the typical lengths that we're expecting based on those design drawings between about 18, 21 meters, ending in that 100 blow glacial till deposit. We were able to put that picture together as part of our desktop assessment, and then moved on. And there was a note, incidentally, in the 1965 contract drawings indicating a design load of 60 tons, which is just about 600 kilonewtons. So taking all of that into account as part of sort of the context for our project. We did step away and work with, and I see some of our structural and highways teammates on the webinar here this morning, but looked at beyond geotechnical conditions and subsurface conditions. We really wanted to think about the geometric compatibility of what we were doing with these bridges, because they do set the stage. We want them ideally to tie into the new bridges that are being constructed to the south, but this is setting the stage for what will happen with the bridges to the north, successively the remaining core lanes and collector lanes and ramp bridges to the north. So we did give thought to either maintaining the current pier locations at these bridges or to completely modifying the pier locations. And within maintaining those pier locations, we've got a range of anywhere from reusing the existing pile foundations with no enhancement or augmentation at all to cutting them off, remove the pile cap, cut them off, no contribution from those piles, install completely new piles. And then there's a realm in between those things where there may need to be some, augmentation, partial capacity with these piles and augmentation of the piles. And those things obviously have risks that go along with them. Risks and benefits, we'll talk a little bit more, not a lot, but a little more near the end of the presentation. But obviously the full reuse, no augmentation does have greater risks around capacity and integrity and durability of those foundations, obvious benefits in terms of cost and schedule impacts, and then those risks decrease, but costs and schedule impacts increase as we go towards the other end of that spectrum. So this was a piece of our consideration and a piece of the backdrop against which we have completed our work. Just painting the picture, these are preliminary GA drawings, and they may not represent what is ultimately built here, but really I just wanted to show sort of the approximate depth of the pile caps and the illustration here of vertical and battered piles supporting each of those existing west and east piers. This is at the Metrolinx rail line, a new west abutment on a completely different span arrangement, and an east abutment that is not too far off of an existing pier, but with differing foundation requirements. And just to note that in this particular area, we have a series of oil and gas pipelines just to the west of the West Pier, and some fiber and communication lines within the rail corridor, very typical here in Canada, but certainly some utility constraints in this area. At Leslie Street, again, just an illustration of that west, center, and east pier. The travel under the bridge in this area in proximity to hospital is very, very tight. We don't have, extra allowance of a lot of, shoulder space and stuff like that. So it's a constrained bridge underneath the highway in this area. But again, those existing piers are shown here. So in terms then, with the backdrop of looking at reuse of these existing foundations, working through the design drawings, working through all of the borehole information, we did work through an assessment of the geotechnical resistance of these existing piles. It is predicated on the design lengths and the design drawings and the original 1960s investigations showing the presence of this very dense or hard glacial till layer in this range of 18 plus meters below rail or Leslie Street grade. And from that information, we assessed capacities that were in the range of 13 to 1400 factored ULS capacities for these piles. And our factored serviceability was greater than that 1400 kilonewton sort of high end of the ULS assessment. We did also review that there was a mid-1960s load test in this area that gave us some confidence around these values. They did not test this to failure. My speculation is that they were going for a lower design load and they only came out with enough weight to test to a certain level, and they did not reach failure at that tested level. So we have confidence, admittedly on a different type of pile section, but that they were able to achieve something greater than a factored ULS of 1300. We took our geotechnical capacities and our structural engineering colleagues, some of whom are on the call here. Meanwhile, we're looking at the total vertical forces acting on the piers for the existing condition, for a likely future superstructure condition. And the conclusion from that was that we would have more than sufficient axial geotechnical resistance on these existing piles based on our assessed capacities for the proposed superstructure loading with those replacements. You can see those, the percent use of the factored axial geotechnical resistance for structural support. Not going into the details of bending moments and other aspects here, that was not as deep a consideration as part of the desktop phase and certainly a component of the detailed design as we move forward. I'm going to turn things over to Riley now to move on to the more integrity, durability aspects of the pile assessment.
Thank you, Lisa. So my focus today will be on the corrosion assessment work and analysis that's completed in support of this project. To date, there have been 3 studies completed over the last 9 years, with the most recent being completed in 2023. General statement, estimating of corrosion losses is quite a complicated topic, so I'm not going to get too deep into the methodologies today, but I will talk about the type of criteria that was used on this project. In this case, there were 2 design guidelines. The first being the MTO gravity pipe design guidelines, and the second being the Caltrans corrosion guidelines. A lot of these guidelines are based on empirical correlations. They've been developed over many years of experience, but they're based on empirical correlations for studies that were completed back in the 1960s. So there's always opportunities to improve, and we're always interested in seeing these sorts of projects. So I'm quite excited by this work. Generally the findings from these testing programs that were completed on this project have suggested soils with corrosivity in the range anywhere from non-corrosive to severe corrosiveness. Quite a wide range, and these guidelines are typically qualitative in nature. They provide a ranking and then prescribe values to use for corrosion allowance. There are additional factors that are not always captured, things like microbiological activity, stray currents, use of de-icing salt that may change the characteristics of the soil over time, presence of organic material or macro effects from the different soil layers or groundwater conditions. So generally just trying to highlight some of the challenges that might be associated with relying solely on a desktop type study. And as Lisa's highlighted, on this project, there was demolition of a former ramp bridge, which had similar service life as the structure that we're trying to reuse, which provided an opportunity to extract pile segments. So those pile segments shown here were subject to visual examination both before and after they'd been cleaned, and then ultrasonic thickness measurements were collected by a specialist corrosion testing firm to provide an opportunity for site-specific data. Next slide, please. So just to summarize that work, it's completed by another firm, but as part of the demolishment, they were provided with an opportunity to make direct measurements of the extracted piles, which is a really, really valuable piece of information to be able to have. Alongside that, laboratory testing was completed, and based on those guidelines I talked about a second ago, the suggestion was that the soils would range from anywhere from non-corrosive to slightly corrosive. The report notes the evidence of a former corrosion protection barrier coating that was described as having long since failed and would have been consistent with sort of bitumastic coatings that were prevalent during that time of construction. The majority of piles showed evidence of corrosion at 2 different elevations, which would be consistent with seasonal variation in groundwater. As the groundwater fluctuates, you get the most active area of corrosion is going to shift between that groundwater level, or in and around that groundwater level. And there was also some evidence of pitting corrosion, which was be consistent with areas where the coating may have failed first and you had a steel exposed. Overall, the extracted samples were described as being in generally good shape, and the maximum section loss reading, individual reading that was measured was 18% after 59 years of service. Next slide, please. So based on this testing, the specialist firm calculated some rates of corrosion for that 60-year service life, and their report suggested anywhere from 0.93 to 2.69 mils per year. It's thousandths of an inch. And it appears that in developing these rates, they used the lowest reading. So if from that perspective, this would represent an upper bound, or the sort of the most conservative reading of that information. There's also some suggestion that since the coating had failed, that they might expect the rates to increase anywhere between 1.3 and 4.6 mils per year. And to put that into context, that highest value there is roughly 3 times the value prescribed by Caltrans for these soils. So when you start to get into those sorts of numbers, making the case for pile reuse is quite difficult. So they provided a forecast, and they suggested after 30 to 40 additional years of service that the piles would be reaching 50% section loss, and provided 2 options for corrosion protection measures, which includes excavation and reinstatement of the barrier coating, and or installation of cathodic protection, both of which would be quite costly options and might get in the way of reusing the piles. Next slide. So this is where the WSP corrosion team was brought in, and we were provided with the data from the extracted piles and completed our own statistical analysis. We've shown a histogram here, the remaining thickness data, and the average in this case was associated with approximately 3% section loss. And you can see there's an outlier value on the very left side here that roughly 0.355 inch range that we believe was used to develop those previous rates. In our experience, these ultrasonic thickness measurements are most applicable to assess the general corrosion rate for driven piles, as opposed to pitting corrosion rate. And so we'll get into that in a second on the next slide. But here we've shown the data with a normal distribution and a standard deviation of about 9 thousandths of an inch. Slide, please. So for our purposes, specifically with driven piles that are not subject to the same constraints as something like a pipe that might carry fluid, we would consider the development of corrosion rates based on an outlier value to be quite conservative. And instead, we would focus on the 95% confidence value for the data set. In that case, that value refers to the point within 2 standard deviations. And on this project, that amounts to approximately 7% section loss. So pretty significant reduction over the pitting value that we saw previously. So we developed our rate, our upper bound corrosion rate recommendation based on the original pile thickness shown here, 30 years of service life of the original barrier coating, and then a total 59 years of service from pile installation to extraction. And we get a value that's approximately 1.08 mils per year. Based on our experience and review of literature, we would not expect the corrosion rates to be linear. So they typically will reduce over time as you get corrosion products that build up at the boundary. And so by specifying a linear rate here, we still do have some conservatism, but we note that our assessment or our approach is more in line with the expected values that come from the Caltrans guidelines. Back to you, Lisa.
Thanks very much, Riley. So from the desktop assessment process that we had gone through, complemented with this cool opportunity to look at an admittedly small sample set, but extracted piles from this structure that was in near proximity to the bridges in question. We have made a preliminary conclusion that both the existing pier piles will provide sufficient geotechnical resistance for structural loading conditions. There's a risk there around the pile length and capacity, but I'll come to that risk assessment in a moment. And from what Riley has explained, a conclusion as well that the limited corrosion that was observed on these extracted piles supports a corrosion rate that would allow a remaining service life of 75 years for the design of the superstructure replacement with foundation reuse on these piers. So this initial desktop process and assessment concluded that reuse of the existing piles is feasible. In accordance with MTO's guideline then, and terms of reference for this project, we did move on to a risk assessment. So that was a more detailed risk analysis considering both sort of engineering and design aspects, uncertainties, risks, as well as some consideration of constructability and construction. I have highlighted a number of these on the right side in this box. It ranged from physical things like the pile length and tip elevation, which then, of course, feed into pile capacity. Was the pile size shown on the design drawings and discussed in some notes? Is that the right pile size? It's unlikely to be a lighter pile section, but nonetheless, a check on that. Spacing, batter, pile cutoff elevation, probably less critical in terms of capacity assessment, but it has an impact around reinforcing steel details for replacement of the pile caps. And then moving on into the extent of corrosion and the corrosion rate and high localized corrosion beyond that general rate, potential for continuing degradation, impacts on nearby utilities. And remember, I noted those pipelines running down the west side of the rail structure. And as part of all of this and thinking around construction, we considered, working near an active rail line, working near a very busy highway, a very busy local road, the constrained construction access and space. And remember, all of this is also associated with a river valley. And between railroad and river valley, it makes for quite difficult access in and out of these zones for heavy foundation construction equipment. And all of this bundled up with schedule and cost. And so we built a bit of a risk register, risk summary, and then looked at mitigation or response measures for all of those and concluded that all of the risks that we were able to identify could be decreased through varying means to a low rating or very low or even negligible in some cases. And the advantages for reusing these piles really quite, in our view, at least significantly outweigh the disadvantages for their reuse. We do still have some decisions to make around things like corrosion protection and some actions in construction around risk mitigation, which I've got summarized here. So, no performance issues on these piles. The capacity is adequate. We have some uncertainties. Some of you on this call, I saw some of our friends from Thurber joining, and certainly they've done some great work, as have our geophysicists around downhole geophysics to try to pick up pile lengths and confirm pile lengths, as that can feed into confirmation of some assumptions in assessing pile capacity. In our case, between pipelines, fiber lines, rail lines, overhead structure, because we are underneath an existing highway deck with limited headroom, busy roadways, et cetera, it's almost impossible to get a drill rig close enough to these existing pile caps to drill and run downhole geophysics to try to pick up the pile length. We haven't completely given up that hope, but it's pretty unlikely. So that's an unknown. The mention I've made and Riley's made about these extraction tests, it's a great sample set, but still limited data, and it is not directly at the existing pile location. So there's some potential of some additional testing that we may be able to do as our investigation design proceed. But what we're looking at as we move toward construction, design and construction is number one, implementing a corrosion protection system for these existing foundations as well as new foundations. So that's stuff that is still to be considered as our detailed design moves forward, as well as a special provision to incorporate into the specifications for this project. The pile cap is planned to be removed for all of these locations, which will opportunistically expose the tops of these piles. And so we're going to have pile driving equipment, very likely pile driving equipment, because we're looking to use integral abutments. So they're going to be out on site. We could take the opportunity when the pile caps come off to run some non-destructive testing. We could do high strain dynamic testing to get pile capacity. We could do simple, pile integrity type testing and measure waveforms to confirm a pile length, and therefore verify and gain even additional confidence in our assessed geotechnical capacities. We can also expose the upper portions of these piles. Water table is not terribly deep, so we've got to, we'll be down to pile cap level anyway, and expose the upper portion of piles, do some visual assessment, do some ultrasonic thickness testing measurements, and just verify that we are consistent or not with the data so far and the assessed corrosion rate moving forward, and then have ready a line item, effectively a design ready to add foundation elements, whether those be micropiles or additional driven piles or other deep foundation elements that can augment the capacity on a given foundation element here, if warranted based on the findings during construction. And that brings us to where we are at currently in our journey around the desktop study, the opportunistic pile extraction study, and the risk assessment that we've done thus far. I want to acknowledge we've got a couple of firms and a number of individuals who've contributed quite a lot to the work that we've been doing as part of this project. Brennan Paving were the firm that they are currently working on the adjacent contract and undertook these extractions, and Glencore did all of this testing. Minkyong and Neem at the Ministry of Transportation, and my colleagues Anna and Will, our senior geotech and senior materials engineers within WSP, and of course our structural and highway engineering colleagues here. But really, ultimately, the Ministry of Transportation and Tony, for your enthusiasm towards expanding the body of knowledge around deep foundation performance in over time, and the integrity and durability of these foundations. Really an excellent case study, and pleased to see the number of these that have developed so far, and looking forward to more of them, certainly.
Thank you for a great presentation, all three of you. For the attendees, please use the Q&A box to get your questions in. You may just stop sharing your screen, Lisa, because it's now going to be probably pretty stagnant for the next 15 minutes or so. And people are probably more interested in seeing the speakers talking about some of the questions. Tony, first one is for you. In one of your earlier slides, you indicated that reuse shall be considered as an alternative. Does it mean that if a bid comes in where the contractor does not consider reuse, that a bid is not accepted or is rejected? How strong should you read that shall be considered as an alternative?
The reference to considering alternatives, Gerald, was more directed to the engineering and design. But we could separate the engineering design from the construction. So from an engineering design perspective, what we're asking our service providers, as I indicated in my presentation, is we want our service providers to take a look at the feasibility, the viability of reuse of existing foundations on every job. We'll make that assessment, and then we'll determine the feasibility. If it becomes an option during construction where, say, a contractor looks at all the information and says, well, you know what, Ministry of Transportation, have you considered the reuse of existing foundations on this particular job? Such a consideration can always be submitted via a change proposal. But the history of change proposals administered at the MTO is such that if it comes to a scope that's extremely large, like such a thing that would require a lot of redesign and whatnot, I think the likelihood of that, even though we would consider it, I think the likelihood of that being accepted would be slim. And that's why we would prefer to kind of put more effort into the engineering and design perspective and have the consideration done at that time.
Okay, thank you for that. Another question came in, Riley, for you, and I combined it with the question that I have. One of the things that you mentioned was that the corrosion rate over time is going to reduce because of the corrosion products already there, which normally tends to lower the corrosion rate. But then you, of course, have always the naysayers or the devil's advocates that says, well, yeah, but what happened in the past is not a predictor of what happens in the future. How certain are you of that? And associated with that is a question that came in as well from Ed Kennedy saying, well, yeah, corrosion rates, how do they, general corrosion rates, but how does it relate to pitting corrosion, which is a completely different type of corrosion rate or corrosion process? How do those corrosion rates relate to the pitting corrosion?
Okay, so to touch on the first one, I would say there's pretty good agreement and a lot of studies that have been done that have shown that the corrosion over time does follow a power law and reduce with time. And the study that I mentioned, it's called, a lot of people know it as the Romanoff study, was completed in the 60s. Extensive, I think it was 20 years of buried piles that were then extracted and demonstrated that behavior. And there's been a lot of work since that supports that. Nothing certain, but it provides a high level of confidence, I think. Sorry, the second question, lost the train of thought.
Corrosion versus general corrosion.
General versus pitting. Yeah, so right. The big challenge here, and is as not being a structural engineer is problem for me in talking about this, so I'll keep it as concise as possible. But you can't predict where those pits might be. So I mentioned it briefly, but if you had a pipe that was carrying fluid and that had a pit, you might be particularly concerned that it's going to fail and have a leak. With a structural element, especially a driven pile, you may be able to tolerate pitting in a way that you may not. And so we tend to look at these from the standpoint of general corrosion for driven piles. Kind of probably all I can say about that at this stage.
One of the advantages that I have as moderator of this event, of course, is that I get to see the slides in advance. And why I was very interested in this particular presentation is this test study. And so I asked Lisa to prepare one more slide because it was not originally there. Lisa, maybe you can show that one now. What is the table of content of your desktop study? And can you say something more, just run us through there to see that the desktop study really covers all the various aspects that need to be addressed to assess the option for foundation reuse?
Certainly, Gerald. So this table of contents is developed largely in response to the ministry's guideline and the terms of reference that are set out in accordance with that ministry guideline. And so if this kind of recaps what we've presented in terms of the process we've undertaken, but we did look at a whole lot of background information. This is a large number of structures constructed in the 60s and rehabilitated a number of times since that time to kind of build that background knowledge, looked at the extensive series of subsurface investigations, both geotechnically and in more recent years in terms of corrosivity parameters for soil and groundwater. Considered all of that background information to look at the capacity of existing piles, then feeding into that table option that I put out around either reusing foundation elements or not, and within the reuse box, looking at not augmenting or fully augmenting or replacing piles. So to me, the first question really was one of capacity, because if we found that we were severely low in terms of, unlikely, I suppose, because the structure has been performing well, or these structures have been performing well, but some changes in codes and some changes in requirements for these structures, there may be some loading increases. If there was some shortfall in terms of factored capacities and resistances, that's a first gate before we even get to integrity and durability. I would say in this case, we were not purely a desktop assessment in that we had this opportunity to look at extracted pile data from a nearby site, which I think greatly enhanced and validated, verified the guidance that's in the Ministry of Transportation Structural Design Manual, which I think closely aligns with the Caltrans guidance around rates of corrosion. So we were able to get some additional validation there, even if it is a small sample set. So this does not include this desktop assessment piece is step one in the ministry guideline and in the work that we did in response to the request for proposal. There is a follow-on piece of work that we've done around risk assessment, as I showed in the slide, where we highlighted sort of the main risks we've identified and then worked through mitigations. So that was a separate document. I didn't actually put that table of contents together, Gerald, but reflecting on all of this, I would certainly say, and Riley's mentioned the Romanoff paper. The Romanoff is thrown around quite a lot in corrosion of piles, and while there have been studies since that time, there's vastly more information for pipeline work, right? And horizontal, shallow or whatever depth horizontal features in generally disturbed conditions are very, very different than the behavior of deep foundations or the corrosion impacts on deep foundations. And so, certainly a takeaway I would have from this beyond simply the desktop is the absolute value of getting data from from foundation elements that have been in the ground for a period of time, and that can give us more localized, beyond just a standard number, really help to consider and refine the projection forward for foundation reuse.
Right. Thank you for that. I think this desktop assessment and the table of content, very valuable for people around the world involved in this whole thing. And hopefully Lisa will present at the upcoming conference in March in Amsterdam more about this desktop study and their approach. She mentioned already in there that it was largely formatted based on the guidelines from the MTO. Tony, is that guideline generally available? Is it published? Because I know DFI, the Deep Foundation Institute in America, and I saw that Andy Buckman, who is the chair of the Foundation Reuse Committee, was online as well during this webinar. They're trying to develop a guideline. Maybe you could say something about the guideline that you have, and can people readily access that guideline?
We do have the guideline, Gerald. I was kind of hopeful that it would have been a touch more advanced, as we have sought some input from our structural folks at the ministry. But notwithstanding, it is available. We have it in its current form. Like anything else that we do at the ministry, we're constantly and continuously trying to upgrade, and we're certainly in the process of upgrading that guideline as we speak, but we do have something that's available in its current state.
And people can contact you to get a copy of that guideline?
Absolutely, absolutely.
Okay, and if attendees don't know Tony's email address, you can always send a message to info@foundationreuse.com, and we'll see it on there. And we might even post it in the resource center on the website, www.foundationreuse.com, so that we have it there as a resource available as well. One final question, because I want to keep it within the hour. Tony, if you could just very briefly answer this question that came in from Brady Lynn. Where are we in terms of the research on province-specific corrosion rates and the corrosion table?
Okay, so we have administered the works through what we call here at the ministry the Highway Innovations Infrastructure Funding Program. So that particular assignment has been awarded. It's been awarded to McMaster University, and it's in progress as we speak. As we typically do with a lot of these research assignments, it starts off with a literature search in terms of what other jurisdictions have done and are doing. So we're at that point right now. The next step would be that we would take a look at projects within Ontario, projects that have been completed, projects where we've got an understanding of the foundation systems and also an understanding of the chemical properties of the groundwater and the soil, which is something that we try to do routinely. That would be the next step in terms of compiling all that information. And then thereafter, of course, it's assembling all this data, trying to interpret the data, analyzing the data, and then trying to put it in some type of format so that we could have specificity here in the province of Ontario to help us out with the assessment of, like I said earlier, the reuse of existing foundations, but also help us out in terms of for future designs, because that's something that we really have to look at moving forward. Of course, the framing of this particular webinar is reuse of existing foundations, but we also have to think about, from a sustainability point of view, what are we going to do in future designs if in fact we are in an environment where there is an aggressivity that is of concern? What do we do? Do we galvanize? Do we go with sacrificial thicknesses? This is something that we're going to determine via the study moving forward.
Very good point, and I wish I had time to address it with you guys. But unfortunately, we're at the end of this webinar. Salita, if you could just go to the next slide. I want to thank again Riley, Lisa, and Tony for giving this presentation, for sharing this information with us. In 2 months' time, we will have a similar webinar, but then a project again or two projects actually from Canada, but a couple provinces over. And there we're going to talk about a project with timber piles and with concrete piles. So these two webinars really cover the different types of piles and how you assess those for reuse. That is in about 2 months, early December. Then, of course, we have the conference in March. Call for papers is still open. If you have something that you want to share for that conference, please submit it. So you can go to the web page www.foundationreuse.com. There you can find all the information on that. And finally, if you are looking for PDHs, just send an email to info@foundationreuse.com, and we will award one PDH for this webinar, provided you were there for most of the time. With that, it's the top of the hour again. Thank you very much for being here. Thank you very much to our speakers, and I look forward to seeing you again, either for the next webinar or hopefully for the conference in Amsterdam. Thank you very much.
Thank you, Gerald and everyone.
Thank you, everybody.